Professor Rob Colwell, you coined the concept of null models in ecology. Can you provide us a simple definition for dummies of null models versus neutral models?
Well, as far as I know, neutral models started with genetic models, looking at neutral evolution, neutral genes, genes that have neither positive nor negative fitness value, and it formed a baseline for understanding natural selection and population genetics. A null model is different in that in a null model you're looking at a process and asking the question, what happens in the absence of some factor that you care about? And the original null models, the paper you're talking about was called A Null Model for Null Models in Biogeography, and with David Winkler. And our idea was to ask what biogeographical processes would look like without competition, and thereby to be able to infer whether competition was happening. This was all in the context of a time when competition was rather facilely assumed to structure all sorts of things, and it was a healthy questioning going on with Don Strong and Dan Simberloff and others, and our contribution to that was to try to do this more rigorously using a model, and the model we used had to do with the structure of communities on archipelagos of islands, with obviously Darwin's finches being the archetypal example, but this was an abstract model, and we wanted to know what would happen with and without differences in fragility, with and without competition, and so on. So you try to build a model that will tell you what a pattern would look like in the absence of a process. So that's the idea of a null model. Neutral model can be process-based, but tries to look at what the background level of variation in some factor. There's an overlap.
And now you are moving towards the development of mechanistic models, but they have strong elements of stochasticity.
Oh yes,
so,
stochasticity is not.
I can see that you are building these models, but you are drawing from your experience with null models.
Sure, and a mechanistic model, we just try to build the process in. The stochasticity is trying to account for historical contingency. There's a lot of different fields of human endeavor in which the question is asked, what might have been if something hadn't happened, if something had happened? What if Hitler had been killed in the attack and then earlier on when he was attacked in his bunker? What would have happened if the Roman Empire had spread eastward instead of westward, and so on? And there are lots of novels and so on that have this sort of approach. So in a biogeographical stochastic model, we can ask the question, how much of what we see today is inevitable, and how much of it could have been otherwise? And the only way to know that is to do a model where you change parameters, tune the knobs on your black box, and see what comes out. And some of those knobs turn out to be important, and some are not so important. Thiago Rangel and his collaborators in 2008, 2007, did a model that tried to answer this for South American birds. And in that model, it turned out that niche conservatism was highly important, and rate of speciation was not, in order to reproduce these patterns. Just an example. So the whole idea of stochastic models that involve historical processes, and biogeography is absolutely intrinsically historical, can ask the question, how important are factors that we put into the model in producing outcomes that resemble or don't resemble what we actually see today.
Thank you very much.